right, so I'm going to talk more about math because, well, that's my life. I'm trying a new headset thing, so I'm curious to know if my sound is any better. If it is, or if it isn't, just basically if you watched this video, if you could let me know via an email and include Mr. Lakin on it, Blaken, if you will, and why don't you throw in a fun meme? Just because. School appropriate, of course, but let's send some fun memes before we go into this 4-day weekend. So if you're watching this, please let me know how the sound is, if it's any better, and send a meme. Okay, we left off with this one. Consider the curve given by this thing, whatever curve that is. Notice this is a curve, not a function, because we've got some y's that are implicit in there. We know that at x equals 3, there is a horizontal tangent, so that means that f prime of 3 is equal to 0. Another way of notating that is that dy dx, when x is 3, is equal to 0. Okay, anytime you start an AP type question, you want to just start pulling out all the information based off of what's given. So we know the curve's first derivative, which would be like f prime, is given by this expression, dy dx. Notice that this expression depends on both x and y. We have the second derivative, which would be f double prime. And if you remember from way back long ago, we notate this as it is the second derivative of y with respect to x. And that's because you take the derivative with respect to x twice. So that's where that square comes from. D squared is like saying the second derivative. Okay? We've got this mess. Is there a local minimum or a local maximum at x equals 3? Well, the way that we determine maximums and minimums, there's two ways, right? We can say, does f prime make a change in sign, right? Either positive to negative or negative to positive. Or we can say, what is f double prime of the number that we're considering? Because I know that f double prime will tell me if I'm concave up or concave down. And I already know from my given information that x equals 3 is some sort of a horizontal tangent, which means I have a max, a min, or potentially neither. Oh, my oven is preheated for dinner. Okay, so how I can do that? I'm going to use the second derivative test because all I care about is, again, what's going on at 3. Well, here's my second derivative. I need to figure out my second derivative when x is equal to 3. Yikes. So 8, I have no idea what y is. 3 times 3, I can do that. 3 times dy dx at this exact moment is 0 because of my given information. Minus 2, minus 3, still don't know what y is. I'll leave a blank spot. Minus 2 times 3. And then I have 8 times dy dx, again at 3 is 0, minus 3, this problem is ridiculous, over 8, still don't know what that darn y is, minus 3, oh wait, I missed one, minus 3 times 3 squared. All right, so this is the derivative of the derivative at x equals 3. All right, so of all this information, I still need to figure out what is this y value. That's my last blank spot to fill in. Well, to find y, I always go back to the original, right? We always go back to the original function when we need a y value. So I'm going to say that 3 squared plus 4y squared equals 7 plus 3 times 3 times y. So let's think about solving this. I get 9 plus 4y squared equals 7 plus 9y. So 4y squared minus 9y plus 2. So if I subtract the 7 to the other side equals 0. When I go to factor this thing, 1 second. Nope, I was just being silly. So I need to do 4y squared minus 9y plus 2. Well, the only way I can multiply to 2, getting to negative values in here, is going to be something with a negative 2 and a 1. I'm going to need and a negative 1. I'm going to need a 4y, squish it in, and a y. So y times 4y gets me y squared, negative 8y, negative y, positive 2 equals 0. You could use the quadratic formula if you wanted. You also could have split the middle term. That's up to you. So I have y equals 2, and I also have 4y equals 1, so y equals 1/4. Wait a second, though. How can I have 2 y's? Oh, no. Okay. Process. Y is 2. Y could also have been 1/4. But only at one of these do I have a derivative that's equal to 0. So let's see if we can find y from this. 0, I get 3y over 8y minus 2 times 3 is 6. 3 times 3 is 9. So if I go through and solve this, I end up with y is equal to 2. Because remember, to solve when a fraction is 0, you just care about where the numerator is 0. So I would add 6, divide by 3. Y is equal to 2. Which means that 2 is my winning value. And if you're sitting here thinking, Ms. Schwartz, would we really need to do this on our own? I would say not yet. That's why I'm here, right now, supporting you, right? So what I am finding is that the second derivative, dx squared, ooh, there's thunder outside, dx squared is going to equal 18 minus 9 times negative 2 minus 6 minus 6 is 0 times anything is still going to be 0 over 8 times 2 is 16 minus 9 is 7 squared. So I'm going to end up with 7 times negative 2 is negative 14 over 49, which means that the second derivative at x equals 3 is less than 0. Okay, well, what was the purpose of that again? Oh, right. If the second derivative is less than 0, my graph was concave down, and when x equals 3, I have some sort of a maximum. All right, so there's a maximum at x equals 3 because f prime of 3 is 0, and f double prime of 3 is negative. So I want to show you the graph of this one because I think it's important for you to see. I mean, all graphs are important for you to see. But this is our graph that we have going on. And so this tangent right here, okay, we came up with the point 3, 1/4, right? That was a critical, or sorry, that was a y value at 3. Wasn't critical though. This was the critical one, right? Because this is where we had a derivative of 0. So at the point 3, 2, at the point 3, 2, I found that my second derivative was negative, and my graph therefore should have been concave down, which my graph is concave down, so I have found a maximum. Now again, it's a lot, but you got to think strategically about what you have versus what you need. When I get to this point and I'm like, oh no, I've got too many y values, think about what piece of the puzzle you haven't used yet. Now, the question comes up, could I have found this y equals 2 just from dy dx on its own? Yes, but generally speaking, I want you guys to get in the habit of when you need a y value or you need a function output that you go back to the original. All right, again, send a meme. Let me know how my audio was. Include Mr. Lakin. He'll enjoy it because he has no idea that it's happening. Okay, great. I'll see you guys later. Bye.